Hey everyone, it's Rachel. Today we're going to learn all about addition and subtraction with different bases. Normally we'd use base 10, but today we're going to mix things up. Our two bases that we're going to use today is base 12 and base 5. For base 12, it's a little bit different than base 10 because for base 10 you can only do values 0 through 9. Anything above 9, you have to regroup and take the base and add that to the number you're carrying. Similar but a little bit different is base 12. For base 12, you have numbers 0 through 11. You can't go above 11, but when you're doing your problem, you have to represent your 10 and 11 bases numbers as A and B. So when you see A and B on the board, don't freak out. Those are our 10 and 11 values. For base 5, it's similar to base 10 except it's 0 through 5. You can't go above 5 or else you have to regroup and add your base 5 to the number you're carrying. So without further ado, let's math and do the problem. To the board. So first we put our value. So remember it's 0 through 11. It can't go above 11. If it does go above 11, then we have to regroup and add our base to the value number we're carrying. So we have 5B910 plus 42834. Now don't forget our base 12. We bring down our base to represent base 12. A equals 10, B equals 11. So we have 0 plus 4. It doesn't go above 11, so 4 is fine. 4 is fine. Uh-oh, 9 plus 8 is 17. 17 minus 12 is 5. So since we have 12 as our base and 5 in our ones place, then we put the 5 down and we carry the 1. 11 plus 1 is 12. 12 plus 2 is 14. 14 minus 2 is 12. So we put down our 2 since that's in the ones place, and our 12, we carry the 1. 5 plus 4 is 9. 9 plus 1 is 10. So our A represents 10. Circle our answer. That's how you do addition problem with a base 12. Now to mix things up, we're going to do a subtraction problem with base 5. A little bit easier, not much busy work. Our values are up to 5. Anything above 5, we have to do regrouping. So let's get started. We have 2, 2, 4, 1, 1, minus 1, 3, 4, 2, 6. Move this over. Oops, I messed up a little bit. 1, 1. Got to make sure they're organized. Our 5s. Bring down our 5 for our base and get started. So I've already noticed that 1 minus 6 won't work because there's no negative numbers, so we have to borrow, but we can't borrow from a 1, so we've got to borrow from our big number 4. Our 4 borrows from our 2 and our other 2, so we're left with 1, 1. Now, when we have a 1, we can't do 1 minus 3, so we change it. 1 plus 5 is 6, so our new carried number is 6. 6 minus 3 is 3, so now it is even since it's a factor of 5. 4 becomes 3. 3 plus 5 is 8, but 8 is too big, so it has to be a 7. 7 minus 4 is 3. Our 1 becomes 6 because 5 plus 1 is 6. So we bring down our 4 and our 0, and our subtraction problem is 3340 to base 5. All right, so those are our two problems. Now to the informative stuff. So now that we've done two different problems, we have to compare it to base 10. How are these two problems different than base 10? Well, for one, base 10 goes up to 10, the number 10, and then after that you have to regroup. So the regrouping factor is similar to all different problems. In every problem using a base, we have to use the regrouping, where we take our base and add it to the number we're carrying to make the value true. But the difference with 12 compared to 10 is 10 doesn't use numbers to represent 10 doesn't use letters to represent the numbers. It uses numbers. But 12, since there's no number 12 to be a digit, we have to use A and B. So reminder that our fifth base cannot go past 5, and if it goes past 5, we have to regroup to get a number that is lower than 5. If we have a base 12, it cannot go above 11, and if it goes above 11, we have to regroup to get a number lower than 11. It's very important to remember that. And to remember that for our bases, oh yes, for our base 10, our last part, the difference is, the main part is place value. So we have our ones place, normally, our tenths, our hundredths. However, if you noticed, in our other problems, we didn't have a setup as a ones, tenths, hundredths. We had a fifth base, a 12th base, and in the place value system, there's no 12th place or 5th place. So that's how you know that it's not a base 10. The base 10 is a number that can be evenly divided, subtracted, multiplied. It can be evenly solved. But with another base, you have more busy work to do. I hope this video taught you more than you need to know about different bases and base 10, and you can be able to understand the difference between a base 12 and a base 5, and the difference between an addition problem and subtraction problem. With all that math aside, thank you for watching this video, and see you guys next time. Bye-bye.